What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 1.7, midpoints and bisectors, kind of a continuation from 1.4 where we talked about distance. Now we're just going to talk about what is halfway through that segment. So we'll be able to find the length of a line segment on a number line, find the distance between those two points in the coordinate plane, and then also utilize midpoints and bisectors. First thing we want to talk about is what is a midpoint and the definition of that. So the definition I have is the point halfway between the endpoints of a segment. So a midpoint can look like this. Maybe we have line segment AB, and then M would be the midpoint of that, because we can prove that by saying that maybe A to M is 2 and M to B is also 2. Okay? Equidistant is just a way that you can state what's happening with the midpoint. So an equidistance just means the same distance a point is from two other points. So in this same example, M is equidistant from points A and B. Okay? So that'll be all we have for the definitions. Let's go ahead and take a peek at our midpoint formula. So our midpoint formula, the whole entire formula we'll use would be x1 plus x2, and divide that by 2 to find your x-coordinate, and y1 plus y2, divide that by 2 to find your y-coordinate. Initially, we'll just start with finding the midpoint of two numbers on a number line, so we can use those as just x1 and x2, but then we'll eventually move on to a pair of coordinates and another pair of coordinates. Okay, go ahead and pause the video here if you need to write it down, and once you're ready to go on, click play. All right, midpoint of x, y, and this actually should say xz, so that is my fault there. Xz, so we have x is -3. We can say maybe this is point x1 and z is x2, so what we're going to do is just add those together. So -3 plus 8 and then divide by 2, or 5 divided by 2, which is about 2.5. So on the number line, 2.5 would be the midpoint of those. You can prove that by just counting in between. This would be 1, 2, 3, 4, 5.5. And then this one would also be 1, 2, 3, 4, 5.5. Okay, so they're both showing 5.5 distance. That's why 2.5 represents that midpoint. Example 2, find the coordinates of M, the midpoint of AB, for when A is -2, 1 and B is 8, 3. So this is when we want to use x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So the first thing I'm going to do is label x1, y1, very similar to distance formula, x2, y2, except now I'm just going to add my x's together, -2 plus 8 divided by 2, and then my y's, 1 plus 3 divided by 2. -2 plus 8 is 6, 6 divided by 2 is 3, 1 plus 3 is 4, 4 divided by 2 is 2, so my midpoint of this line segment on the coordinate plane is 3, 2. Midpoint's very good whenever you need a small amount of time to find a midpoint. Otherwise, you could technically draw these points on your coordinate plane, -2, 1, and then 8, 3, and then find the distance, but then you'd have to think about, how long is this, where's halfway. Example 3 is on the back of your paper, so let's go ahead and flip that over. Now we're going to talk about this. Find the coordinates of A if P is the midpoint of AB, and B already has the coordinates of 8, 3. So let's go ahead and say that this is x2, y2, but we don't know our x1 and our y1. So what we would need to do is think about if my x1 plus x2, so x1 plus 8 divided by 2 is equal to that 3 they already gave us as the midpoint, and then y1 plus 3, which is that y2, divided by 2 is going to give me a half, or 0.5. What could I do here? Some things I consider is, well, first maybe I would set this up as an equation. So like x plus 8 divided by 2 is equal to 3, and to solve for x, I would multiply both sides by 2. So I would get x plus 8 is equal to 6, and then subtract 8 from both sides. I'm going to get the first coordinate, -2. And then for here, I would just say y plus 3 divided by 2 is equal to 0.5. Again, multiply both sides by 2 first. So I get y plus 3 is equal to 1. Subtract 3 from both sides. I'm going to get y is equal to -2. So my x and my y's are both -2, -2. Okay. Last little bit, a bisector or bisecting and what a segment bisector is. So a bisector is, I'm going to go ahead and type this one out so we can quickly go through this. When a midpoint separates a segment into two congruent segments. And then a segment bisector, we'll draw pictures in a second. Any segment, line, plane, or point that bisects a segment. Okay, so let's talk about what these can look like in terms of a drawing. So a bisector, or when we bisect something, you want to think about midpoint again. Okay, here's point A, here's point B, midpoint's here in the middle, and what we're going to notice is it's bisecting and making two congruent segments. Okay, so this is where it is bisecting, or this is a representation of what bisect look like. Okay, a segment bisector is the segment, line, plane, or point that bisects a segment. So this is also considered the segment bisector. Okay, so pretty easy. What we're going to do now is apply that to the next two examples. Example 4, find the measure of RT if T is the midpoint of RQ. So if I know that this is the midpoint, that means that this is my segment bisector, which means TQ is equal to RT. So I would just be able to say, okay, 2x plus 3 should be equal to 4x minus 5. So I'm going to solve for x first. I'm going to subtract my lowest coefficient with my terms, hopefully to not have to deal with negatives. So I'm going to get 8 is equal to 2x, so x is equal to 4. And then I'm going to plug that back in to RT, because I want to know the measurement of RT. So 2 parentheses 4, and then add 3, or 8 plus 3 gives me 11. Okay? So I'd write RT, RT equals 11. All right, example 5. Try this one on your own. Pause it. When you're ready to check, click play so we can see how you did. Okay, find the measurement of AC if B is the midpoint of AC. So if we know that B is the midpoint of AC, that means AB is congruent to BC. So 5x minus 3 excuse me, is equal to 2x plus 9. Let's go ahead and solve for x here. 3x is equal to 12, so that means x is equal to 4. Now I want to know AC. Technically, I can write an entire expression to add everything together, or maybe I could just take AB, which is 5x minus 3, plug that in, plug that 4 in, so that's 20 minus 3 is 17. If AB is 17, guess what? BC is also 17. So for AC, I would just add two 17s together and get 34. So AC equals 34. Okay, that'll conclude our notes for today on lesson 1-7, midpoints and bisectors. Thanks so much for tuning in, and we'll catch you next time. Have a great day.